con Daniel Pyrathon che ci parlerà di Meta API, Yesterday e Tomorrow. Grazie.
Grazie. Okay, so today I will speak about the Meta API. So my talk will be a journey from what the Meta API is and how it is implemented, what the Meta API looks like now after Django 1.8, and finally a vision for the future, and hence the name Yesterday, Today and Tomorrow, which is a reference to a very beautiful film if you haven't seen it. So a little bit about who am I. I'm originally from Rome, and I lived in the UK for 4 years and a half, and I just recently graduated. That's my beautiful picture of my graduation. It's not Photoshop. I'm also a Google Summer of Code. I used to be a Google Summer of Code student. For Google Summer of Code 2014, I refactored Django's Meta API, and this is the reason I'm very excited about it, and this is the reason I try to speak about its possibilities as much as possible. Another thing, I currently work at a company called Pathflow, where we do computer vision mixed with some business intelligence, and it's a very interesting company. If you are in Rome and you're interested, please let me know. So, I'm aiming to all different kinds of audience. So those who don't know what the Meta API is will have a brief introduction to what the Meta API is. Then we're going to speak about, the talk is going to be divided into 3 parts, which is yesterday, so a definition of what the Meta API is and how it's actually used. Today, which is what the Meta API looks like after a lot of the refactoring cleanups that we did for Google Summer of Code and Django 1.8, which is now stable. And finally, tomorrow, which is, as I said previously, a vision for the future, as well as a very, very small and interesting example, which I built. So first of all, let's start with yesterday. So what is the Meta API and why should we care? So who has used the Meta API here? Okay, well, you know what the Meta API is. So it's a hidden API it's an internal API which is hidden under the underscore meta object of every model. Every model we have inside the system contains this object, and it's used to introspect attributes on top of that model. So it's the way Django uses admin or model forms or any of the high-level components to actually understand more about the model and the way it actually behaves. So this is basically what makes most of Django's model magic possible, because if it wasn't for this API that could provide this type of layer of introspection, it wouldn't have been possible. Other important thing is the API is private, or at least it used to be private. Up till 1.7, in 1.8 now it's public, but previously it was private. So all of this was actually supposed to be used internally to Django, and that's it. But as we'll see later on, it was actually used in other parts of the API too. So, as I was saying previously, the Meta API contains a lot of metadata which is on the model. So for example, we have fields on top of the model that are defined inside this Meta API. We have a system which defines model inheritance. But we also have sort of lower level things in the API. So from the abstract concept of, for example, fields, we have also lower level things like database table, permissions, and everything that is relevant to Django's system to make it work well. So who actually uses the Meta API? There are multiple, let's say, consumers, the way I call it, of the Meta API. So as I said, model form is one of them. Model form manages to generate dynamic forms just by giving it very little information. You can give model form the minimum information possible, and it manages to generate valid and dynamic forms for your templates. You have the admin. The administration panel manages to generate multitudes of URLs, dynamic pages, and does all the things which model form does, just by giving it, just by registering some very, very simple, with just one line, basically. We have the checks framework, which is used under the hood inside Django to make sure that there aren't any inconsistencies when you define models, for example. So an example is for many-to-many relationships or things like this. Django does a lot more checking to make sure that there is integrity and consistency inside your model definition. Serializers are also a big let's say, point of reference. you can serialize a model just by passing a model to Django, and it will automatically understand the fields that needs to be serialized and send them back. Migrations, inevitably. But what's interesting is that while all these green parts inside of the system are actually parts that are inside of Django, the red ones are actually parts that are outside of Django. And these are third-party apps which are publicly used and widely deployed. I guess many of you have used, for example, the Django REST framework, and they are so indispensable for Django's entire ecosystem. But they still use internal APIs that are private and could potentially break from one day and the other because no one documents them and no one actually wants you to use them. Still, they are very, very fundamental for the entire Django community and the ecosystem in itself. So now that we understood a bit about where these actually APIs are, let's have a look at how a model is actually built, how the metaclass system is actually built. So this is just, let's say a map of how metaclass actually is inserted inside our model. So we define any model. In this case, my model is called my model. And it inherits from model, like any model that you would define. Model, in turn, inherits from model base. And model base inherits from type, and it is a metaclass constructor. So what happens is, as soon as your model is imported, the metaclass constructor prepares the model, and it does all the work for you. So, for example, it adds the meta attribute, it adds the object, so what we call the manager, the model manager in this case. And by the time you import a model, all this is actually done for you, and the model is returned. And this is what makes Django so great, that this just happens under the hood, and you have no clue of what's actually happening. And but under the actual people that implement Django have to do a lot of work to make the framework so usable. So this is just a little bit this is taken from production code, but it is sort of scaled down to hopefully be understandable by everyone. And these are, let's say, the 5 main steps for. Can you read it or no? Not really. You can. Okay. Well. Anyway, I will speak about them. So the first step is actually, let's create a new class object. And this is not a class instance, it's an actual class object component of itself. It's basically calling the super, in this case, so the super new of model base. The second step is, let's add the options object with all the informations taken inside the class meta, which is a class which is defined inside your models. So you usually use this for plurals and most of the information that is the metadata of the model. Well, in this case, it's actually pulled out from your model and it's added inside this options class, which is the class that we use throughout the system. So you see this add to class quite a bit, and this add to class is an interface that is widely used inside Django's code base. And what it actually does is it creates a little bit of coupling between the components. So in this case, it's just a common interface that is used throughout all the types of models and fields to do this binding sort of interface. So on step 3, we get all the field names and the field instances, and we add to class those. And in turn, add to class also adds them to the Meta API. Finally, we add the manager. So what we use all the time for objects and underscore default manager and all this. And then once all this is done, we basically call underscore prepare because we have all the dependencies in, and we just need to build a class. We build a class, we register the model, and finally, once the new class is returned, it's already possible to use it to do querying, to do reverse relations and everything, and it becomes quite simple. So what's actually inside the Meta API? At least I'm speaking about yesterday, so before 1.8. Before, as I was saying previously, this Meta API was never documented or actually intended to be documented. So most of the components inside the system were quite redundant. So there was a lot of redundancy inside the system. And there was also no tests, direct test, in terms of this was never been treated as a component of itself. So it wasn't independently tested. And also there were a lot of entry points which were sparse throughout the system. Who's ever used the Meta API knows that there are lots of, let's say, common patterns inside it. For example, get fields with model. Get related objects with model. So, it's very clear that there is a lot of redundancy inside the system. And while I was actually designing the new API, I had to, let's say, make a trace of what the old API looks like, and this is what it looked like. It was, let's say, quite tangled up. And so that brings me to today, where my API has finally landed inside Django 1.8. It's, if you download Django 1.8, you will have it, and it is treated as a component of itself finally. It has its own test suite, and it has a lot more documentation. Well, it has documentation. So this is just a small overview of, let's say, a high-level overview of what the Meta API looks like now. Let's say of the result of my Google Summer of Code. So we have two main entry points inside the system. We have get fields and get field. That's it. And let's say the concept of it is that you don't have to repeat yourself. These are the only two main parts that you're going to need, because the rest of them you can derive. We have one centralized cache layer, which is used throughout the entire Meta API, and it actually connects all the models together. By having one centralized cache layer, we also have the benefits of it. So for example, if I have one cache layer, cache expiration is far easier and far less complex to maintain. It's treated as a component, so it has a whole entire test suite for itself. And there is also a lot of documentation, which I definitely do not take credit for, because Russell, which was my mentor and a great Django core developer, did a lot of work together with lots of other members of the community. This was basically a joint effort throughout lots of the people in the community. One thing I'm also very proud of is that there is 100% backwards compatibility. So if you are using the Meta API, I do encourage you to upgrade, but if you do update from Django 1.7 to 1.8, you will still be 100% backwards compatible with warning. So we're going to send you a warning saying please update, and we're also going to tell you how to update, but we are not going to basically make you fail your system. One thing is, definitely the API is more compact, but this is just showing the public API. So if you look at the design of before and the design of now, there is definitely a lot less redundancy in terms of these are the main entry points. There are other parts of the system that are there, but I'm obviously not showing them because they're not part of the public API. So this is what the public API looks like. This is what's maintained. And as I said, there's only one way to do it, so it's far more Pythonic. Get fields returns a list of fields. Get field gets a field name and returns a field instance. As simple as that. And it's very, very explicit. If the field doesn't exist, it will explode saying there is no field. Field does not exist, error. Instead, the fields will contain not only fields that are concretely implemented on top of the model, so for example, an ID field, a char field, a datetime field, these main components, but it's also going to contain reverse fields. So what are reverse fields? If I have model A that has a relation that points to model B will indirectly have a reverse field to model A, right? And this is what creates that sort of binding, which makes Django so simple to use in terms of, you don't need to know a lot about the way Django actually builds its queries under the hood. Well, at least you need to know if you need to optimize it. But in general, like any user would be able to use this API, and that's what makes it so simple. So those are reverse fields. Reverse fields are fields that don't really exist. They're not concretely implemented on a database, but they are, let's say, consequences. So I'm not going to speak too much more about this. This is the Meta API, and if you want to know more, you're going to actually have lots of these components let's say rediscussed inside my talk, which you will find, which you will find here. The Meta API, a journey of optimization and design. And this is actually going to tell you a lot more about, this is a talk which I did at Amsterdam at the Django Under the Hood conference, and it tells you more about the internal implementations of the Meta API. But let's move to the truth. So let's say that we're really happy about this new implementation, and the benefits of the API are quite obvious in terms of Django's internal development. It's obvious that having a public API is great. But what about third-party package developers? Will they be able to, now that this API is public and people actually use it, will they be able to exploit this API in a better way? Will they be able to customize Django better by having this API built in? And so this is what we, so in order to see that, show if it could be possible, what I wanted to do is, show what we have here. Let's say in order to, let's go back. In order to actually show that this could be possible, I wanted to actually build a proof of concept that could be showed to everyone in terms of, this is actually a vision that I have. And this sort of concept is what I call a less tightly coupled concept of Django's, let's say, API internals. And this definitely would bring a lot of benefits. Now that we have this API, we could, less tightly couple things, make them more abstract between them, and just as long as people implement a custom interface, then we'll be able to use this throughout the entire system. And so in order to make sure that it was possible, I built a model, at least a Django custom store, the way I like to call it. That is a proof of concept, so it's not used for production. But what it does is that it connects to Gmail's API, maps to Gmail's API to communicate with, on one side, Django's admin and the model forms and all those great components. But on the other side, we'll be able to communicate with Django's REST API, and so do a lot of great work over there. So this is the vision, this is the plan, okay? I'm going to build this component, a model, which is not really a model because it's not implemented from models.model. It's a custom created component which is completely duck typed. And the plan is that I'm going to make it work with model form, admin, and the checks framework. So I'm going to make sure the system actually works. And it's going to be treated as a model because indirectly it is, because it implements all those interfaces. And so, as I said previously, this is just to prove a point. It's not to use in production. And it's to show off I wouldn't say, in this case, the Meta API features, which is not the API itself, because the API is quite simple, but to show what this abstraction could actually bring to. And it's what could be, for example, a potential future for the Django project. By the way, these are all my words. They're not words of the Django community. So if you have to blame someone, blame me. And yeah, finally, because no one has actually done this, and it also makes sense too, because who would ever want to build a Gmail model inside of Django? It would be highly inefficient. But let's see what we can get to, and hopefully someone more intelligent than me will. Lots of people are more intelligent than me, so hopefully you will come there and work on this proof of concept and make it even better. So we have to start somewhere. So we want to build let's say we want to build a system. Where do we actually start? Let's start by creating a new application. So in this case, my application is going to be called Mail Checker, and create a fake model that inherits from object, right? So here is my model. Here is my model. And it inherits from object. It doesn't inherit from model's model. So, obviously this is quite non-Django. This is not a non-Django way of doing it. Then what we do is that we add the fake application to the installed applications, and then we register our fake model inside the admin, right? 3 main steps, just like if you'd have to do it with any model. What happens after? What do you think happens after when I run server? This happens. It completely blows up. And this is inevitable in a certain sense. We are actually, the Django system doesn't really care about the fact that it doesn't inherit from model to model, but it doesn't actually implement those interfaces. So what we're going to do is we are going to implement the minimum viable interfaces for it to actually work. So we are going to look at the stack trace, learn from the stack trace, implement those interfaces, write minimal code for it to work, and then we refactor and test. What's interesting is that the best thing that actually helped me building this hack is test-driven development. In fact, let's say this type of hacking and testing go really, really together, because if you think of, you're building this sort of custom part, which is the system which is not meant to build there, you're not going to have the errors that you're going to expect from a framework like Django. And so by refactoring and testing, you get a far better understanding of why those components exist, why they are there, and as I said, it's the best way to actually understand Django's internals. So just by trying to re-implement smaller versions of them myself. Finally, this would never be possible if it wasn't for duck typing. So this is, this is a really great feature, and this is what helped me build this component. So, just as everyone knows, if it looks like a duck and it quacks like a duck, it must be a duck. And, we could sort of convert this in a Django way of saying this. If it looks like a model and responds like a model, if it implements the same interfaces that a model does, well then, it must be a model, and the system doesn't care. So what we started doing is we started saying, okay, well, let's start a look at Gmail's API. Gmail's API contains lots of, let's say, main resources, but the ones which I cared about most were message and thread. A thread has many messages, and these are the entry points that we have inside Gmail's API. And Google also provides us with a Gmail wrapper, which is the Google, let's say, APIs, which are implemented in Python, and they're very, very easy to use. So you have you understand how the create, read, update, delete, let's say, components, the CRUD components inside of Django can be mapped to these APIs. Not necessarily easy, but some of these components can be mapped to the API. Second thing we decided to do is look at what about the resources themselves. What fields should get fields returned, right? So the meta object inside of each model, this customly made object, which in this case will not inherit from options. It will be a custom model which I will make. What resources, what fields will they actually return to us? So in terms of a thread, I just want an ID. In terms of a message, an ID, a thread ID, because we're going to actually be building reverse relations too, forward and reverse relations. Sender, receiver, snippet, and body. So these are the ones I decided to use. And this is an overview of, let's say, the main components and APIs that I actually re-implemented inside the system. So we have a model with we have a default manager in this case, which is actually a binding for objects in this case. So it's the same, it's a default manager. The manager had to implement most of these properties, which actually proxy to the query set. The query set is basically let's say the stateful part of Django's ORM, which actually keeps track of the type of, let's say, query you're trying to do. So an example is you're going to do order by or something, and you're going to return a new query set object which has that information inside. Then you're going to call limit, and that's going to basically append to the previous query set and create a new one. So what's interesting is that this is sort of it's a stateful component, and every time you apply something on top of it, it doesn't mutate, it creates a new object. And this is a very good design. And by implementing it through test-driven development, you actually understand how the query set works, and this was by far the hardest component to actually implement. The easiest was the beta API, because it was just two functions, right? So you just implement those two, and it tended to be sort of easy to actually get those fields returned, because we don't have to handle any sort of reverse relations in this case, because we built them in. So these are, let's say, the main methods overwritten. And we also, this excludes, let's say, the main, we have to also override len, wrapper, iter, and all these, let's say, main things to make Python happy, to make Django happy. But it didn't take too much time to do this, actually. So this, this is the whole picture. It took, I would say, about 2 days in total to to let's say understand this and build it, but slowly. It wasn't too hard. And so I love live demos, and so what we're going to do now is we're going to actually email Giovanni. And let's have a look. So this is my application, right? It has, oh, sorry. There you go. So this is my application. It's just a custom Django application, isn't it? What's interesting, though, is that it has my administration panel. It has messages and threads in this case, right? And while you think that they look like Django models themselves, and they are part of, they're implemented as a models.model, they actually aren't. What they contain is all information coming from Gmail. So in this case, any one of these is actually a thread inside the system, which is a Gmail thread. Also have messages in this case, where I can, let's create a new message, right? So my sender in this case is going to be Django mailer for PyCon. The receiver in this case is going to be, what is Giovanni's email? Giovanni@pycon.it. Yes. Ah, Giovanni, how are you? So, dear Giovanni, it's so nice of you to come here. Okay? Nice. Okay, let's send it. So what happens here is, this send button is actually going to call the ORM under the hood, but the ORM is our implementation. And so what it's actually going to do is it's going to send an email to to Mr. Giovanni. Also, is there any voluntary here that would like to receive a nice email? Anyone? Okay. Let's have a bit of fun with this. Let's go back to messages. Create a new message. Federico. Gmail.com. Is that correct? Yes. Ciao, Federico. Yeah? Yes. Okay, let's send it. So what's interesting is that when we get the email, right, we also get this, which is in this case, it's our sort of primary key. Did you receive it? Yes. Okay, well, wait a second. The demo isn't actually finished, okay? I want to actually show you a few more things. So this is our primary key in this case, right? So it's not a normal primary key. It's a different sort of, it contains also, alphanumeric, so I had to override some behavior. The cool thing about, Django, obviously, is the fact that, we don't need to necessarily use the administration panel, but, as long as we implement that framework, it's available everywhere. So an example is, let's go message objects, right? And this is my message class. And let's get, with the primary key in this case, of this. See? There you go. There's my message. Okay, so just now call Gmail instead of calling the database, and they got my message. So I can do body in this case, dot body, and I get ciao Federico. So Federico, as I said previously, a thread has many messages. So it's a thread system inside Gmail, right, which groups the messages. In this case, now I'm going to do the reverse relation, and it says, oh, you already did. Thank you. Okay. So in this case, look, Federico has actually answered my email. And in fact, it says that our model has two. So which way do we want to see it? Do we want to see it with the terminal, or do we want to see it with the actual admin framework? How do we find out what he actually answered me? What shall we use? Terminal. Okay, terminal. Let's be cool. So this is my thread. Okay. Let's go. So my thread is equals to that. Now, how do we do how would you do this in Django? Thread.messages, right? Thread.messages. There you go. Here's our two messages. Let's get the last one. So let's see what Federico wants to tell me. Oh, okay. Dai. Thank you very much. Obviously, there's a lot of, this is HTML type of email, so there's obviously some complexity in that. But what's interesting also is that, as I said, this is our thread component. And, for example, we can just pull out the ID in this case. And we can also have a look at, our Gmail panel. So let's go on threads. Yep. This should be this one here because it's ordered by last email. Yeah. Okay. So, we can also write back here. Okay. This is actually, this is using oh, sorry. No. Oh, and you also have validation. So now I clicked enter by mistake and it says, okay, well, enter a valid email. So, you have all the, you can abstract a lot of the implementation of the ORM in this case, but use, some of the great components inside of Django. So this is actually, by mistake, I also showed another interesting feature, right? So in this case, I have Django mailer for pycon@gmail.com. And then, what is your email again? Is this correct? Okay, let's write back. That's it. And let's save. Ta-da! Okay. So now you should receive also another email. You received? Woohoo! Okay. It works. Prego, esatto. Okay, so just to wrap up, okay, so this is my live demo. It strangely works. I also implemented filtering, so you can. It just maps to the main API. This is just a few pictures. So we implemented. We have the administration panel working. Oh, sorry, these are my slides. Let's pull down. So we have the administration panel working. We have all the types of other parts of the system working. Funziona. And the interface exactly remains the same except for one part. Can you guess what it is? What is the main part that makes you understand there's something strange here? The primary key, right? Autofield in this case is alphanumeric. It contains, it's a different type of primary key. It's a string, so with all the negative aspects of it. So this is just to speak a little about about this CRUD matrix. Not all the time this is possible. Not all the time there is a compatibility inside it. There must be let's map actions that actually mean something together. This is this is a good method for a common, let's say, CRUD interface, but maybe not everyone will be able. Not every API works with this. So an example is the Twilio API might work with this, but it might not implement the delete method. Gmail in this case, you could map trash to the delete method in this case because in Gmail you can't actually delete mails. You can just trash them and then you can delete them. So a few just a little post-mortem. Yeah, I had to override autofield. Meta was really easy to implement. So I definitely advise you, if you want to have fun, you can try with that. And you need to know a lot about Django's query set. And there's also a lot of security concerns in this case because you're keeping API keys. The other things, this is the only change I did inside Django's framework. Inside Django's source code, I just did one change, which is this. I just removed a check asking for a strict model. And personally, I think that we shouldn't be tightly coupling things. If it quacks like a model, if it looks like a model, then it should work like a model. And therefore, I don't. This is the only strict check that has to be removed inside the system. Second thing I did is, we have some cache properties inside of the Meta API to make it more performant. What I had to, instead of re-implementing all those cache properties, which are fields many-to-many, and those are used inside of Django, one thing which we could do is actually move them inside a mixin. So move all those components inside a mixin. The cache properties actually used get fields. So if we move them inside a mixin and re-implement options with the cache properties mixin inside the Django source code, then we can just create our Gmail options with cache properties mixin, and this should work. So, are we ready for custom stores? Personally, I'm really excited about the amount of work which was able to be done in in very little time. But still, I personally say no. There are too many internals that need to be overridden. And although the Meta API is public, we can even make it better. So for me, the answer is no, but we're getting there. We are definitely going towards a solution where if the community wants to go towards a less tightly coupled vision of things, we can achieve. Django has a great place in this, with a lot of work inevitably. And yeah, that's all, folks.
Domande?
This thing that you just showed reminds me of Ruby's active resource. So maybe in some time it will be possible to implement something like that. Do you know active resource?
Personally, no, just the name.
It's basically allows you to use APIs like models.
Okay, interesting. But the problem is that there are lots of concerns in doing that. What we have in a relational sort of concept of things, where you have resources and create, read, update, and delete, that doesn't necessarily map to all the APIs, right? So this is just a proof of concept. We need to find a domain where this is good to be done, right? This doesn't apply to anything, to everything. So I'm personally, very discouraged from using something like this with all generic APIs, right? They need to map to the Django's relational concept of a model, right? Where you can filter, you can order, you can, create, read, update, delete, and everything. But that is the main key. Unless if they don't map to it, then it's probably better that we implement things in a different way.
Okay, another question?
So do you think would it make maybe sense to move part of the manager interface into the new Meta API so that you have one consistent entry point and just have to override the Meta object? And how would it look like maybe?
That's interesting. In terms of the manager, the manager was actually quite easy to mock up in this case. What I would definitely do, I'm saying, I speak in terms of the Meta API because that's the thing which I have most experience on top of it, and it's basically a proof of the design that we've built throughout the numerous times we spoke with the community is good. The only thing is that we have to if we want to move towards a vision where everything is less tightly coupled, then we need to create more of these mixins where these cache properties or anyway these parts of the system are outside and can be re-implemented on top of a public API.
Thanks.
You talk about backward compatibility.
Yes.
And the documentation is in some way...
It's great documentation because I didn't make it, Russell made it, so it's very good. So the API is entirely documented, okay? It's also documented doc strings inside the code and everything. All the backwards compatibility calls, we created a decorator which is called raise warning, and what that actually will do is it will continue running, but it'll actually say this API is not public anymore. It's not public. It's not available anymore, and we also give you a suggestion. So what we do is we tell you, because we are not removing any sort of functionality, we're just basically telling you another way of implementing it, probably an easier way. Okay? So don't worry about it. It'll be very intuitive to migrate to a new API, hopefully.
Okay. Another question? Okay, thank you.